Hello, my name is Craig Clare, and my project for this semester is the optimization of squat rack safety. This is my progress report, so here's my checklist so far of what I've accomplished. What I've accomplished is in red, and what I still have to do is in black. So as you can see, there are still a lot of steps I have to take, but I feel like I'm in a good position at this point. I will go into each thing in a little more detail, but one thing I want to point out that the current products that I researched to decide the dimensions and the material that I was going to be using were Rogue Fitness and Legendary Fitness, which in the fitness industry, especially equipment, they are two very, very large names. So after researching these two companies and the products that they produce that would be a competitor to my safety design, the material they used was steel, and that's because it's cost effective, it's strong, and it's very available and very machinable, so I decided to keep with steel as well. The range of the products dimensions are different for everyone, obviously. So the length was from 20 to 31 inches, and I decided 24 would be a good one because that restrains it to a certain length and making it smaller. The width I decided to be 2 inches, and then the height I decided to be 14 inches, which I hope through the optimum solution will be smaller than those dimensions. So the scenario I'll be modeling is the bar drop, which is a common industry test where a weighted bar is held on someone's shoulder and they simply drop it from that height. And so what I found was the competitor Rogue could withstand 800 pounds, so that's something I'll be aiming for. To keep it simple, I'll keep the force uniform across the thickness, and the location of the force will be applied at the end of the safety because that'd be the worst case scenario. The magnitude I found, which I'll show you on the next page of how I calculated, will be 178.5 kilonewtons. And the two constraints, so I'm basically modeling this as a cantilever beam, and so one end is completely fixed while the other one is a free end where the force will be applied. These are my calculations. As you can see, it's a very simple set of equations I used, and I think the assumptions I used will be good. They could be tweaked later on to maybe produce a more accurate result. So that is where I am so far, and hopefully the rest of the semester goes this smoothly.